I think it would be worth our time to take a step back and take a look at the, what was it called? The molar mass. Molar mass. It's another stoichiometry term that is very useful for us here. All right. And the molar mass is a way of describing how much mass 1 mole of a substance has. For this, you're going to need a periodic table. If you don't have one, pause the video and go grab one. Now, molar mass is the amount of mass. Oop, let me get going here. I didn't even set this up. Take a nice, what do we want to, how about a black background again? All right. Anyway, okay. And let's try a different color. Let's go with the yellow this time. I think yellow will look good. All right, that's good. There we go. Now, molar mass is the amount of mass a substance has per 1 mole. Right. So if you have 1 mole of an element, like just 1 hydrogen, it has a mass of 1.00794 grams. Now, you can see this on your chart. If you don't see it, take a look at carbon. 1 mole of carbon has 12.011 grams. All right, I'll do one more and see if you can find the trend. 1 mole of boron, that's atomic element number 5, has a mass of 10.811 grams. All right? And we can do this with even more elements. We can do it with molecules, like a mole of H2, which is the same thing as a mole of H and a mole of H. In other words, there's twice as many hydrogens here. This has 1.00794 times 2 grams in it, because there's twice as much hydrogen as up here. I can pull out a calculator, and we can see that real quick. 1.00794 times 2. So this has a molar mass of 2.01588. 2.01588 grams. Did I get that right? 2.01588, yeah. All right. And the trend continues. We can take a mole of something called methane, CH4, all right, and it has a molar mass of carbon, which is 12.011, plus 4 hydrogens, 1.00794, times, how many of them do we have? 4. Okay. Now, this is just an algebraic statement. Throw this into a calculator, and you'll find out the mass 1 mole of CH4 has. And remember, while we're doing this, the purpose of this calculation is to find out what we call the molar mass. It's the amount of mass in 1 mole of a substance. Oops. 1.00794 times 4, and that's 4.03176. 4.03. Sorry, I've got a memory like something's got a really bad memory. 176, and this carries down 12.011, and now we'd have to add this number, 12.011 plus 12.011. So the molar mass of the CH4 or methane is 16.04276. 04276. I wonder if this has a way where we can always keep it on top. Possibly, probably not. Let's try to basic take on sheets. Nah, we're just gonna have to deal with it. Okay. Anyway, this has 1 mole of CH4 has this many grams of mass. We call this the molar mass because it's the amount of mass in 1 mole of a substance. Now, why is this useful to us? Now, in the last video, if you remember, we dealt with ways of finding out moles of one substance when you know moles of another. Well, when we're doing experiments, when we're doing measurements in chemistry, we don't always know how many moles we have. Sometimes we have other units. I said there's 2 ways of measuring the amount of, well, stuff we have. In chemistry, one of them is the mole. If you have a mole, you have a certain amount of that substance. Well, mass is another way of describing how much of something you have. And much like if I have, I don't know, 13 eggs, or better yet, 13 bagels or something, we know that that could be represented in other ways. That's a little bit more than 1 dozen. That's actually 1 dozen plus 1 extra. But you can see we have different ways of showing the units. We can either just say there's a certain number of them, or we can use dozens, other ways of measuring how much of something we have. Well, moles and mass are the 2 ways that we describe how much stuff we have in chemistry. So it's nice to have a way to go between these. If I know how many moles of a substance I have, I know how much mass. And likewise, if I know how much mass of a substance I have, I can find out how many moles of it I have. For instance, if I have 2 moles of carbon, all right, how much mass is that? Well, 1 mole of carbon, we've already said, is 12.011 grams, so twice as many moles should be twice as much mass. In that case, it's 24.022 grams of carbon. See how it works? Now, what if we have something awkward? Like, say we have 19.5 grams of carbon. Well, now we're to the point, just like we were when we originally got a little bit confused, going from moles to moles. Instead of doing it in our head, let's use a little bit of math. We know this comparison here. This one here with carbon, that's my son if you can hear him. He's into chemistry as well. 1 mole of carbon is 12.011 grams. So we can make up a ratio of those. 1 mole of carbon is the same thing as 12.011 grams of carbon. And likewise, we can flip this upside down. 12.011 grams of carbon is the same thing as 1 mole of carbon. Remember what we did in the last video? We ended up using one of these ratios to help solve this problem. And how did we always decide which one we wanted to use? Whatever our unit was on top, grams of carbon, was the one we had to have on bottom, grams of carbon. So we can come up here, we can take this ratio, use it in our problem. We don't need this one anymore. I'll put an X through it since it's kind of overlapping. And now we've got our little statement here again, our mathematical statement. Grams of carbon, cancel the grams of carbon. We have 19.5 times 1 divided by 12. 19.5 times 1 divided by anything on bottom, 12.011. Where's that calculator at? We have 19.5 times 1. You don't really have to do that. I'm just doing it for demonstrations. Divided by 12.011. Awesome, a bunch of digits. Mr. Schlecht, how many of those digits do I need to use? Oh, a few. We won't bother with significant figures. But let's keep 2 of them. Let's say 1.62. 1.62. And we always need a unit. What's the only unit we have left? Just like before, it's the only one that's not canceled out. Moles of carbon. There we go. There's the first example. I'll create another video. This next one will be Chemistry Stoichiometry 2B. See you in a bit.